So the first things that we're going to look at with chords today are some important theorems dealing with angles or arcs in a circle. You'll notice that these two theorems are listed here on the screen. They are also in that student note sheet if you're using that. If you're just writing these notes in your notebook, make sure that you get these two copied down because these are our first two theorems for today, and they're going to be really important as we look at some problems with chords. Okay, so this first theorem says, if two chords in a circle are congruent, then their central angles are congruent. And so what that means, you see this diagram over here, what it's saying is if these two chords, right, remember a chord is a segment from one point on the circle to another point on the circle. So if those two lengths are the same, then their central angles are also the same. Okay, so if MN, which is this segment right here, is congruent to QP, if those two lengths are congruent, then what that means is that then angle MTN is also congruent to angle QTP. So if the chords are congruent, the angles are congruent. The next one says that if two arcs in a circle, remember that our arcs are those parts on the outside, right? A portion of our circumference. So if these two arcs are congruent, then their chords are also congruent. So if those two lengths around the outside are congruent, then we know that those segments are congruent. If this is actually an arc, so you see this is a little bit rounded, it's hard to see there on the screen, but if arc MN is congruent to PQ, then our segment MN is also congruent to our chord or segment QP. Okay, so those are our first two theorems. Now let's look at a couple of things with these theorems. The first one I want us to think about is, where does this property come from? Why is this always true? How do we know that this chord is the same length as this chord? How do we know that? Well, let's look at a few things that we know. We know that all of these sides must be the same, right? They're all a radius going from the center to the outside, so all of those have to be the same length. We also know that these angles right here must be the same because these two angles are vertical angles. Okay, so that's how we kind of build this triangle, and because of side, angle, side, these two triangles have to be the same. And so if they're the same, then those third sides must also be the same. Okay, and similarly, if we look at it the other way, how do we know that those angles are the same? Well, again, we know that all of these side lengths must be equal. In this problem, they told us that our chords are the same. And in that case, these two triangles must be similar. By side, side, side. Right, we know those lengths are all the same length, so the triangles are going to be exactly the same. Okay, so then we can know that those angles on the inside have to be the same as well. And so that is really the property that we're looking at, right? If we step back here to those theorems, we're going to do some work with these, knowing that our chord lengths are the same. If we can prove that the central angles are the same, or if we can prove that the arc measurements are the same. So let's look at a couple of practice problems. So here you see our first problem. We know that these two lengths have to be the same. And so if they have to be equal, 4 has to be equal to x, then this side must be 4. If we know that these two chords have to be the same, it means that 5 has to be equal to x plus 2, or x is equal to 3. Right? If we know that these two central angles have to be the same, we know that that 40 degree must be equal to x plus 10, which means our x is going to be a measure of 30. And so we can use those properties to solve for some missing values or missing measurements in our circles.